Hi guys, in this video I'm going to discuss how to find firm output and price when firms maximize total revenue. So the appropriate diagrams that we need are here. On my curves I have demand and marginal revenue, that's up the top, and on the bottom I have total revenue. Now I do have a more detailed video all about these diagrams, so what they mean, why they have the shapes that they do. So I'll link to that video in the description. For our purposes, what we want to find is right here. So the quantity and the price that's associated with this point where our total revenue is at its highest or at its maximum. So there are a few ways to find this point, though in this video I'm just going to use the method where I set marginal revenue, which is the first derivative of our total revenue function, equal to 0. And the way this works is that marginal revenue is actually equal to the slope of our total revenue function. If we have a look at our bottom diagram here, we can see that the slope of our total revenue function is initially positive, but it does get flatter. The slope is exactly flat at the maximum, and then it becomes negative. So at that peak point that we want to find, that's exactly where the slope of our total revenue function is equal to 0. So to demonstrate, I'm going to consider an example where my demand curve is expressed by the equation Q is equal to 5 minus P on 2. So here Q is quantity and P is price. Now the first thing I'm going to do is I'm going to rearrange this expression until price is on the left-hand side and isolated. So you'll see why I do this in a second. It will make it easier for us as we're going through. So to do this, I'm going to take away 5 from both sides. I'm left with Q minus 5 is equal to negative P on 2. Then I'm going to multiply both sides by negative 2, and I get, just opening out that bracket, negative 2 times Q plus 10 is equal to, well, the negatives will cancel out here, and so will the 2's, so equal to P. And I'm just going to rewrite this as P is equal to 10 minus 2Q. I have P on the left-hand side and the positive value written first. Sometimes this is called an inverse demand curve. Now to find our marginal revenue function, we need to take the derivative of our total revenue function with respect to Q. So I'm going to need to find our total revenue function. Now total revenue is equal to P times Q. What we can do is substitute our inverse demand function in for P. Now we find if we do that, that total revenue is equal to, well, P is equal to 10 minus 2Q, all multiplied by Q. That's equal to, if we open it out, 10Q minus 2Q squared. Now if we take the derivative of this function, we'll get our marginal revenue function, and we get 10 minus 4Q if we do that. Now I've used some calculus here. If you're unsure about how to take derivatives, I do have a video that I'll link to in the description below that will hopefully make that step clearer. Now what we're going to do, we're going to set this function equal to 0, and then we're going to solve for Q. So we get 10 minus 4Q, that's marginal revenue, is equal to 0. If we add 4Q to both sides, we get 10 is equal to 4Q. We can divide both sides by 4, and we get Q is equal to 2.5, so the quantity that maximizes our total revenue is 2.5. On our diagram, it looks like this. We found that the quantity that corresponds to this highest point and that point where our marginal revenue function is equal to 0, that's equal to 2.5. To find the price associated with this quantity, we're just going to substitute this value back into our demand curve. We can use our demand curve as I originally wrote it with Q on the left-hand side and then solve for P, or we can use the inverse demand curve because P is on the left-hand side and that's neater. So I'm going to do that. We find that the corresponding price is, well, P is equal to 10 minus 2 times 2.5, which is 10 minus 5, so 5. So if I put this on the diagram here, I can draw up to the demand curve and across, and that's the associated price. Now it's worth noting that if we have a linear or straight line demand curve, and we do in this case, then this point where our total revenue is maximised actually corresponds to the midpoint of our demand curve. So this is really a second or a different, perhaps in some circumstances easier way to find our maximum of total revenue. So before I end this video, let's see this. The first thing we're going to need to do is to find the intercept values for our demand curve. So on our demand curve, the price axis intercept occurs when Q is equal to 0. So I can find that point if I substitute Q is equal to 0 into our demand curve, or I can use my inverse demand curve. So I'm going to do that. And we can see that if Q is equal to 0, then P is equal to 10. So that's our price axis intercept. Now our quantity axis intercept can be found by setting price equal to 0. And I can use, again, my original demand function or my inverse. I've been using my inverse, so I might as well use my inverse. And we get 0 is equal to 10 minus 2Q. Let's add 2Q to both sides. We get 2Q is equal to 10. Then we divide by 2 to get Q is equal to 5. And so what I wanted to show you is that the point that we found previously, 2.55, this point is exactly at the midpoint of the demand curve. And so we can see that because 2.5 is exactly halfway between the origin and 5, and 5 is exactly halfway between the origin and 10. So if we wanted to just quickly find the maximum total revenue, you could do it this way. The only thing that you need to be careful with if you're going to use this strategy is just to make sure that your demand curve is indeed linear, so like a straight line. And so that's it. I hope that helps you at home. Have a lovely night or day.